Hello everyone, this question has been taken from Olympiad Pathfinder, Chapter 12, multiple choice question number 20. The question says, consider a thin conducting shell of radius r carrying total charge q. 2-point charges q and 2q are placed at point A and B respectively, which are at distances 0.5 r and 2 r from the center C of the shell respectively. If the cell is earthed, how much charge will flow to the earth? So let us solve this question and see which option is correct. We have collected all the data over here. Thin conducting cell of radius r. Cell is carrying charge q. At point A, charge q is placed. At point B, charge 2q is placed. So what is to be found? If the shell is earthed, how much charge will flow to the earth? So let us focus first on the charge status on the shell when a point charge is equal to q kept at location A as shown in the figure 2. All the field lines due to the point charge at location A will fall on the inner layer of the thin shell and will cause a charge q in equal to negative of the q charge to appear at the inner layer. Therefore, positive charge q out will equal to q will appear at the outer layer, because this q inside is appearing due to the movement of all the electrons towards the inner layer due to the attraction of the charge kept at location A. Further, the shell was initially with charge q on it, so all the q charge will be experiencing a repulsive force and will be on the outer layer. Go through the write-up. The cell already has the charge q per the question and will stay at outer layer due to repulsive force by the charge q at A. So therefore, total charge on the shell now will become q is if we say it as capital Q, that will be equal to small q plus q in plus q out. But q in, we know that it will be negative of the q, so minus q small q, and q out will be equal and opposite to this minus q charge, so that plus q, so capital Q will be equal to small q. This has happened when the charge of amount q is kept or placed at point A. Now finally a charge 2q is placed at a distance 2r away from the center C and the shell is earthed. So what will do this earthing? Earthing will cause the potential 0 on the shell. So let's say q dash is the final total, q prime is the final total charge on the shell. So potential due to charge at B on the shell surface plus potential due to the total charge q prime on the shell surface will be equal to 0. So k into 2 Q divided by R will be the potential due to the charge at B. Why this R, small r is involved here? Because the nearest surface from the point B to the conducting shell is r distance away, and the entire cell will have a zero potential. So if we take the potential at the nearest point from the point B on the conducting surface, so it will be represented as K into TQ divided by R. Plus, now we know that total Q prime charge is there on the shell after earthing. So K into Q prime divided by R will be the potential due to Q prime, and that will be equal to 0. So Q prime will be equal to minus 2Q. This is number 2 equation. So the charge that has drained to the earth will be the total charge on the cell after the Q was placed at A minus final charge on the shell after the charge 2Q was placed at B and the shell was earthed. So capital Q was the charge on the cell after the Q was placed at A. We have already discussed earlier on it. And final charge on the cell we are representing as Q prime. So if we put the value of a capital Q as Q from equation 1 and Q prime from number 2 equation, so it will be coming equal to 3Q. Means 3Q charge has been drained to the earth from the shell. So if we look into the options, answer B is correct. You can go through the note. The nearest surface of the shell from the point B is r distance away from it, and the whole of the surface of the shell is 0 due to earthing. Therefore, potential due to the point charge at B is K into 2Q divided by R, as has been used in this equation. So trust you have understood the concept of solving it. Any doubt, please write in the comment box. I will try to clarify. Thank you.